So in example number 3, we're finding the multiplicative inverse using matrix multiplication. So here's our given matrix. A is equal to 1, 2, -2, and -3. So in step 1, for this method, we're going to multiply matrix A by a matrix containing unknown constants and then set it equal to the identity matrix. So here's our matrix A, and these are the unknown constants, A, B, C, and D. And we're going to set it equal to the identity matrix. So what we can do is we're going to multiply, in step 2, we're going to find the product of the two matrices on the left side of the equal sign. So when we multiply, we're going to get 1 times A minus 2 times C, 1 times B minus 2 times D, 2 times A minus 3 times C, and 2 times B minus 3 times D. And on step 3, we're going to set up a systems of equations with the entry in row 1, column 1 of the new matrix equal to the first entry of the identity 1. And then we're going to set the entry in row 2 equal column 1 of the new matrix equal to the corresponding entry of the identity, which is 0. So what that means here is if we take a look at the matrix that we solved here, we're going to take 1A minus 2C and set that equal to 1, which is what we get here. And then we're going to take 2A minus 3C and set that equal to 0. And then what we're going to do is then we're going to use addition by elimination to be able to solve for one of the variables. So what we can do is we can multiply the first equation by -2 and keep the second one the same. So -2 times 1A is -2A, -2 times -2C is plus 4C, and -2 times 1 is -2. And then we're going to keep this the same as 2A minus 3C equals 0. So now when we add those equations, we can eliminate the A, and we get 4C minus 3C, which is C, which is equal to -2 plus 0, which is -2. So now we know what C equals. And so now we can solve for A by using back substitution in either one of these equations. So with the first equation, we have A minus 2 times what we got for C, which is -2, and that gives us plus 4. And subtract 4 to both sides, now we know that A is equal to -3. Okay, now in step 5, what we're going to do is then we're going to be able to solve for B and D doing the same procedure. But now in this scenario, we're going to let 1B minus 2D is going to equal 0. And we're going to let 2B minus 3D equal. So now we have those two equations here. 1B minus 2D is equal to 0. 2B minus 3D is equal to 1. And then we're going to use addition by elimination again to cancel out the variable B. We're going to multiply each term by -2. We get -2B plus 4D equals 0. And then 2B minus 3D is equal to 1. So we can eliminate the variable B. And 4D minus 3D is D, which is equal to 1. And now what we're going to do is we're going to back substitute to solve for B into the first equation. So we get B minus 2, which is equal to 0. Add 2 to both sides. Now we know that B is equal to 2. And now we're going to substitute back in what we got for A, B, C, and D into the A, B, C, D matrix. And that's going to be our inverse. We know that A was -3. We know that B is 2. We know that C was -2. And we know that D is equal to 1. So this is one method of being able to find the multiplicative inverse of a matrix.